All right, good morning, good afternoon to everybody that is on the line. We are going to get started with today's webinar. We really appreciate you guys all for being on with us today. I'm sure some more people will trickle in as we get going. We're really excited to get started with today's webinar. It is the Dynapower Energy Toolbase CNI Storage Integration webinar. Throughout the next 30 to 40 minutes or so, we're going to be talking about our latest commercial storage integration with Dynapower, which will allow our ETB developer users to run energy storage simulations and analysis that represent how Dynapower energy storage systems, controlled by our Acumen EMS controller, will operate in the field. Today, we'll be touching on who Dynapower is, the hardware specifics of this integration, the application process, and we'll also be showing you some CNI project case studies modeled in our platform. If you're already a platform user, you might have already started using this integration. It launched a little bit ago, and you might already be modeling some storage projects with it. If not, we always want to give our users another option to modeling storage with one of the industry's leading hardware providers as the storage market continues to grow and evolve and more projects get deployed. So we are joined by some really awesome speakers. Matt Simo is a regional manager at Energy Toolbase. He works closely with our customers. He helps them manage their accounts and projects, and he's oftentimes working on storage projects using our integrations within the platform with our customers. He's going to be overviewing the application process later on and those case studies I mentioned. Kevin Mulvey is also on with us. He's the manager of product and technology at Energy Toolbase. He's heavily involved in getting integrations launched, and he manages kind of all the storage integrations launched, including Dynapower. We're also joined by Alan Gregg. He is the applications engineer at Dynapower, and he's just going to be giving an overview of Dynapower and the hardware specifications. So before I pass it on to them, I kind of want to talk about something important. We had a big update to our ETB developer platform, which is the solar and storage modeling platform that the Dynapower simulations are going to be ran in if you choose to use. Some of you might already know or are already using the V4 platform. I know we have some users on the line right now, but we just released a big software update to that platform. Our new update, which we do refer to as the quote unquote V4 release, is really one of the most significant updates we've made in a very long time. If you're a user, you'll be able to use, if you're not a user right now and you sign up, you'll be on this V4 platform. If you're a current user, you obviously still have the option to opt in to use it. So some of those V4 features, the V4 platform combines new features and functionalities with the same familiarity of our workflows beforehand. We have some new user interfaces. We have new features like the proposal configurations feature, which allows users to pre-configure proposal inputs and settings like general information, transaction documents, and so on. We have some new cash flow capabilities within transactions and incentives. And we've really completely upped our utility rates capabilities, which we're excited about. ETB developer can accommodate daily demand charges, daily and hourly real-time pricing charges. We've also added a few new features in there like demand ratchets, charge types, and we track generation charges at a line level item within our database. We also just dropped, maybe last week, I think, some new really awesome document templates for our users, and we've enhanced our net metering capabilities. We track utility territory specific NEM details, value of imports, exports, and non-bypassable charges. So those are just some of the highlights from V4. If you are modeling with this integration, you will see in the platform. And that's just going to help you streamline your projects, including your projects with Dynapower. So this partnership really makes us even more excited with this V4 release for you guys to use. With that being said, I am going to let us dive into the integration details. So I'm going to pass things over to Alan from the Dynapower team.
Okay, it took me a while to unmute there. Sorry, Tracy.
No worries, we can hear you.
Yeah, okay, do you hear me now?
Yep, you sound good.
Okay, all right, I just wanted to briefly introduce myself. I'm relatively new with Dynapower, but I've been around the industry for a number of years in, had the advantage of working both on the user side and the manufacturing side. So I tend to have a good perspective on products as well as applications. Some of the companies I've worked for in the past, if you've been around for a while, you may recognize some names: United Solar, Satcon, Sungrow, and also Energy. But anyway, I've been with Dynapower for long enough now to pretty much understand all of the products and the applications. In fact, just yesterday, commissioning a system not too far from where I live in Michigan. It's a place called Cadillac, Michigan, which is an interesting little town. But anyway, it was having field work also adds to the full understanding of a product and how it works and how to make it work. So it's all good. Dynapower's been around a long time, since 1963. And I'm sure that was before a lot of the people that are working in the industry today were even born. But it's grown into the leader, I would say, in energy storage systems, as well, in particular DC coupled systems, which is its biggest claim to fame in the energy storage and renewable energy industry. But Dynapower is also in government defense systems, part of the Patriot missile program, and so they have a wide range of capabilities and history in multiple industries, and currently expanding into hydrogen, electric vehicles. So really a fully faceted company, very interesting and fun to work for me. I'm enjoying my time. Dynapower designs and manufactures the products, but in addition to that, with the exception of the batteries, they don't make the batteries, but in addition to that, we provide integrated energy storage systems for both behind the meter and in front of the meter. And we've done systems in many countries. I don't know off the top of my head how many, but of course our focus is the US, North America. So we provide everything from small scale stuff. The site I was commissioning yesterday was 500 kilowatts, and then to 100 megawatt systems. So it's the full range of capacities as well. And the micro power systems, the MPS line is Dynapower's newest line of products, and it focused on the commercial behind the meter energy storage systems. So Tracy, you want to go to the next slide? So this is a graphic of the MPSI, meaning integrated system 125 EHV. And the inverter itself, the battery inverter, is the box that's hanging off the right side of that illustration. The other two symbols are the HVAC systems to keep the batteries cool. So this is a package. In fact, I was just on a call earlier today, and we're in the final stages of the development of this is 125 kilowatts maximum, and we're just finishing off a similar system, the MPSI 250, which has two of the 125 kilowatt inverters on it for a total of 250 kilowatts capacity, and a 2-hour energy storage package. So in this package, the features include the AC overcurrent protection, DC disconnect switches, integrated DC fuses, and redundant HVAC cooling systems, which is nice because you want to make sure the batteries don't overheat. There's integrated fire suppression system, AC-DC switchgear. The DC precharge circuit is included in this package. It's optional for the inverter. So you can have your own pre-charged circuit if you're just buying the inverter, but for this integrated system, it's included. Now this data sheet that is shown on this slide, it says Black Start is optional. It's no longer optional. It comes free, no extra charge. And then the dynamic transfer, which is a patent feature allowing automatic, well, it detects the status of the grid, and if the grid goes down, then within somewhere between 2 and 8 milliseconds, the inverter signals it has dry contacts, which basically activate a remote switch, which disconnects the grid. But the loads, the way the circuit is, the loads are connected to the inverter. And so the loads are supplied during that transfer. And so it almost acts like a UPS. It's not totally like a UPS, but that's the close proximity. The data sheet, if you have good eyesight, you can read all these numbers. It's actually an older data sheet. And the 600 volt version of this package is not available. Dynapower made the decision not to only go with the 480 volt system. So this data sheet, I didn't notice it when I first looked at it, but it's outdated. So we have to ignore the 600 volt part of the data sheet, and just the 480 volt is correct. Okay, you can go to the next slide, Tracy. Okay, the other product, and this is an earlier, probably the first product that Dynapower made in this market, is a DC to DC converter, which allows for DC coupling, integrating solar PV with energy storage. So I would say that Dynapower is a pioneer in DC coupled systems. There's the AC coupled systems where you have a PV system and a battery system, and they're connected on the AC side. Okay, so you essentially have two inverters. On a DC coupled system, in the first figure there, DC coupled PV plus solar, you have a PV inverter, and then you have your solar connected to the PV inverter, and you also have Dynapower's DC to DC converter connected to the same connection point. And then the DC to DC inverter uses PV power, uses PV energy to charge the battery. The battery discharges through the DC to DC converter and supplies the PV inverter. That system is great for using any excess PV energy to charge the battery. You store it, and you can use it anytime, or you can use it to smooth out the variabilities in the solar resource. But it will not operate off grid. If you want to operate, if you want to provide resiliency and operate off grid, then you need the reverse DC coupled system there shown in the other figure, where the PV is connected to the Dynapower DC to DC converter, and that charges the battery. And both of those outputs are then connected to the, in this case for commercial applications, the MPS 125 EHV, which is the inverter that was on the outside of that package that we saw in the previous slide. So then all the energy coming from the PV is captured either in the battery or supplied as direct current to the input of the storage inverter. But that inverter has the dynamic transfer capability. It can operate either on or off grid. So there you have kind of like the best of all worlds. If resiliency is one of the requirements, that's the way to go. If it's not, then you can go with the other configuration showing the PV inverter as the AC supply to the grid. So that's about it for me. Tracy, I guess Kevin's going to take it.
Yeah, thank you, Alan. That was great. Appreciate you walking us through Dynapower's array of product. And I just wanted to take a quick second, as I have been, excuse me, I have been working with Dynapower for probably close to a year now, just kind of getting everything dialed in for this platform launch. As a lot of our users know, it's already been up for a little bit of time now. Yeah, it's been great working with the Dynapower team. Their products definitely fill a lot of the gaps that we're seeing in the market. One of the things to note is that, as a lot of you know, working in the industry, these projects can have a lot of variances and become somewhat complex. So the platform is great for modeling, the bulk of the projects that you're going to run across. But we also have abilities to really kind of work with the developers using the ETB platform on kind of building out these kind of DC coupled options or backup microgrid type things that might require a little extra support from our account management team. Matt can talk a little bit on that and walk you through what you can do on the platform that we already have set up. So yeah, I'm excited to really kind of get this ramped up, work with our developers using the platform, and kind of be partnered up with the Dynapower team to deliver these energy storage projects.
All right, Matt. Yep, I just shared to you. Cool.
All right, Tracy, you got my screen?
Yep, it looks good.
Excellent. All right, thank you so much, Kevin, and thank you, Alan. Again, my name is Matt Simo, Regional Manager here at Energy Toolbase. Do a lot of support here on the account management side, working with clients in the field to develop and help pass this along to our customer success team to get these things deployed. So what I want to show you here, I'm just going to run through a couple different tabs just through our ETB platform, just kind of show you how the Dynapower integration works. It's super easy. It literally couldn't be any easier. So that being said, let's kind of start off. I'm going to run through a time of use arbitrage example of just how the Dynapower system paired with our Energy Toolbase Acumen controls could effectively shave energy. And then I'm going to roll through a peak demand shaving example as well. So really quick, let's take a look at the energy profile. Just kind of see what we're working with here. Just at a high level, our seasonal profile here overview is going to say, we're going to start ramping up our usage typically here in the morning about 7:30, right? A pretty even, consistent load throughout the day, and that's going to kind of taper off later afternoon. And we kind of see that consistent pattern here just throughout the full year cycle. Consumption-wise, pretty typical of what we see, maybe like a medium or large kind of scale office. And the rate tariff that we're using is a TOUD. And I'm going to return back to this here before we actually start modeling the actual batteries. So I want to take a look at some of the charges that make up this rate. And then as we move into the demand profile for the peak demand shaving example, this is the example we're kind of going to go with. It's a much more spiky sort of load profile. And the reason we went with this is because specifically telling these Dynapower batteries powered by Acumen controls, we want to be able to target these specific peaks and then shave those down to make a nice level net energy profile. And therefore, right, we're going to get our demand savings. So just a quick overview, just kind of what we're working with. And starting off, right, time of use arbitrage. So at a glance, for anybody that's on the webinar currently that has done work in our previous version, version 3, this is the V4, right? It's a much anticipated release. We're super excited to kind of have this pushed out to our user base. So that being said, you can kind of see some differences here. For those of you that know V3, everything's on one page now. So at a glance, you can see the entire project. Navigating through this is much faster and easier and a lot more intuitive. So what I want to take a look at here, just high level, the nature of the project itself. We do have a PV system in here. It's a 300 kilowatt DC rated system. I priced it about $217 per watt, pretty appropriate for a system that size. The average savings we got is 17 cents. And we're going with the TOUD rate out of Southern California Edison. So before we get into the actual energy storage, this is kind of a quick coaching sort of segment here, is we encourage all of our users just understand the rate tariff that you're using. It's very important. It's one of the main drivers behind the economics behind having energy storage pencil in these projects. So Let's take a look really quick into the rate itself. We're going to click here, show rate schedule details. And it's going to open up another tab here. And once we open this up, we're going to be able to see what comprises this actual rate. So here we actually have no demand charges, okay? So this is going to be perfect for kind of showcasing the TOU arbitrage sort of aspect of our controls and Dynapower's hardware. Clicking into the rate, we can see we do have time of use, all right? Mid-peak in the winter season is 37 cents, off-peak is 14 cents, super off-peak is the same price. In the summer season, right, we have a much larger spread. We got 15 cents on the low end, right? Mid-peak's about 30, on-peak is 41 cents. So ideally what we want to do here is we want to charge our battery as cheaply as possible, discharge here on peak and gain that difference, okay? So that being said, let's take a look into the integration. So once we kind of get the energy profile built, the PV system, we're going to dive into energy storage. So once you're going to do that, here's what it's going to look like at a glance. When you first click into energy storage, you're going to see a lot of different options. Now, if you're a brand new user, all of these options are not going to be kind of lit up, right? They're all going to be grayed out. So you first have to get approval to use these integrations. Super easy to do. All you do is click on the integration. A box will show up, and you just click the button that says I accept. It'll send your application in for approval. We usually have a turnaround about a day or so on those. So once you get approved, okay, you're going to have access into the Dynapower integration. And once you have that access, it's going to look just like this. So what we have here is the system cost, okay? And again, once you're approved, our Energy Toolbase account management team can help get you the pricing for not just the Dynapower hardware, but also pairing with our Acumen controls. So we can help get that pricing over to you, and then of course add in your margins and any other expenses involved with the installation. But the first step here, right, ESS design. Okay, so within this integration, we're going to click this drop-down menu, and we're going to see 4 different systems. So first and foremost, we got the Dynapower MPS 125 kilowatt 2-hour battery. One of the options I believe Alan was discussing just a few minutes ago. We have the same system with a 4-hour discharge. Okay, so same power rating. We have twice the capacity. Then we have our 250 models, both in a 2-hour and a 4-hour option. So the first step is to go ahead and select which battery you might want. Okay, second step, ESS control settings. Okay, we have all of our Acumen capabilities and controls preloaded and ready to go. So we can take a look and see what's offered. Okay, and the reason why I kind of went back and looked at the rate is that understanding the rate tariff will help you guys choose which of these options is most appropriate for the nature of the project. So here, starting off, we have our Acumen EMS, demand charge management, and TOU arbitrage, no charge restrictions. So this one specifically would be intelligent enough to shave energy or demand, but not charging from PV, all right? No charge restrictions is saying that we're gonna basically charge from the grid. We have our Acumen controls, demand management, TOU arbitrage, specifically charging from PV only. We have a self-consumption mode, okay? And this is for one of those scenarios where it just might not be a very valuable rate tariff. We could just not have a time of use sort of rate that we're working with. So we're gonna effectively charge from PV, and we're gonna discharge to offset our imported energy. There's no price signal taken into account with this control strategy. Okay, so when PV winds down for the day, we're going to discharge the battery to offset our imported energy. We have specifically a TOU arbitrage, no charge restrictions, and then the same with charging from PV only. So we kind of got you covered, right, from pretty much whatever rate tariff and scenario you're working with. And as Kevin mentioned before, just a few minutes ago, that if you need something more advanced, we absolutely can work with you guys to do backup power and even microgrid capabilities. So just let us know what you need, and we're happy to dive in there and help design and model this out. So if you're asking yourself, how do I know what battery to use? Okay, we have a couple different options. How do I know what's most appropriate? Well, this button right here on the right-hand side, ETB Optimizer. This is a fantastic simulation engine. And what we call is kind of a backwards facing engine. When you run this simulation, it's going to do so based off of these selections, all right? So whatever ESS design that you chose and the controls that you paired up with it. So when you run this, okay, it's going to give you 6 different charts here on the left. You can just kind of click through some of these different results. And effectively what it's going to show you is 10 different systems, right? So it's going to start off at the very base here at the 125, okay, because that's what we have modeled, the 125 2-hour. And then should we double that system, right? Triple it, quadruple it, right? All the way up to stacking 10 systems together. Now, whether or not you can do this in the field, right? We would need to talk to you and understand the nature of the project. But analytics wise, we show you from 1 to 10. We can show you the blended savings, right? This is a very important aspect, and understanding which Dynapower system is most appropriate for this opportunity. So for example, if we installed this first one, this 125 2-hour battery, 372 kilowatt hours, our blended savings is $50, right? $50 and change. So $50 per kilowatt hour. So what this means is that for every kilowatt hour of capacity that battery can hold, we're saving our customer $50. So the most value, right, is going to come when this is the highest number possible. And what we would consider a pretty valuable opportunity is, you know, about maybe $40, $45 blended savings and higher. So to see one here paired with PV and still have a $50 blended savings is really good. But naturally, as you say, hey, what if we stack that battery? The blended savings drops a little bit because we're adding more capacity. And yes, we are adding more savings, but you don't always get that proportion. But this is a really fantastic tool within the integration that helps you understand what might be the most cost-effective battery for your opportunity. And of course, we have demand savings, and here this rate tariff has no demand charges whatsoever. So now this is 0. Total bill savings, annual peak demand. We can see what's happening with our peak demand as we add more and more batteries. And of course, what we're exporting to grid. If you guys are working in markets where you need to be very conscious of that, prime example is Hawaii market. If you export to grid, you get 0 money, you get nothing. So it definitely pays to be able to size the battery in such a way to eat those exported kilowatt hours from the solar and then discharge later to either shave energy or demand. So once we go ahead and hit save on this, okay, let's go back. This is what our output looks like, okay? So we kind of went forward and moved with the 125 kilowatt 2-hour battery. So once you hit save, okay, you're gonna see this sort of summary detail. And we got our cost here. Okay, I priced this battery at $270,000. There's our discharge duration, our charge and discharge power, round trip efficiencies, right? The actual equipment, annual cycles. Okay, this is an important one. If you're modeling in California and you're going after SCHIP, you definitely want to make sure that you're cycling enough to get the full base incentive of SCHIP, which is 104 annual cycles. So looking at this, yeah, we're definitely in the clear for that. And again, what you're discharging and what your losses are. So it gives you a great comprehensive overview. And then down at the bottom, we have costs and incentives. So what you would want to do here is click on edit selected incentives and choose the incentives that are going to be appropriate for the nature of your project. And of course, up in the corner, blended savings. Really important to keep your eye on this one here, just to make sure that the value opportunity is as great as possible. So really quick, let's take a look at ETB Analytics. I just want to quickly review visually kind of what we're looking at in terms of performance of a strategy just like this. So let's just kind of click and expand on a few days here. Let's actually just do just a couple more. Here we go. Okay, so let's just kind of start really quick with the basics, and then we're going to move on to peak demand shaving. So here's our current demand, okay? So this is called the demand visualization, as we call it. So visually, you can see exactly what we're pulling in from the utility. At the very bottom of this chart, we can see January 8th at 2 p.m., okay? This is what we're pulling in, 130.68 kilowatts. We can also see what the energy cost is, right? So this is at 14.6 cents. And now we're gonna see that step up in the TOU to 38 cents. Next thing we're gonna do is overlay our solar that we built. We can see when that occurs in correlation with our consumed energy. And now we're gonna start looping in our batteries. So here we can see, right, moving into this next day, this red line is our state of charge, 3% state of charge. So now what we're doing is we're charging our battery up because I specifically told the controls to target the TOU arbitrage and to charge from PV. So here we're over-generating with our solar, we're charging our batteries up to full capacity, and we're gonna hold that charge, okay? Because our batteries know that if we discharge right now, we're gonna lose money if we discharge at the same price point. So we're gonna hold that charge until we cross that threshold here on the rate, and now we're gonna start to discharge. We can see that state of charge, that red line value drop. We can see our battery discharging, again, down to 3%, so we can repeat the next day. So this is a perfect example of how TRU arbitrage works to capture energy at a low cost and discharge at a high cost, and bringing down our net, okay? Our light blue as low as possible. And again, we can see this, you know, on the full range of kind of how this is working, okay? So this is a great insight into what you're actually building and to visually understand this. So the next thing I want to look at here is going to be peak demand shaping. Okay, so on the peak demand shaping side, okay, again, we're using a load profile that's a bit more spiky, and the reason we're doing that is just to showcase how well the Dynapower hardware and Acumen controls can target and identify those peaks and shave those nicely to a nice level demand. So what we're working with here, this load profile was considerably bigger. So the DC power rating of our PV is 521 kilowatts, again, priced pretty accurately for a system that size, around $2 a watt, a little bit more. And with the energy storage, we have the Dynapower 250 kilowatt 2-hour battery. So kind of the same thing, right? Click into here, and we're going to open up this integration. And like I said, the 250 2-hour. So really looking at this one, like I said, the controls are smart enough to understand what rate tariff that we're looking at within Energy Toolbase and what amount of effort we want to put towards shaving demand versus energy. So what I mean by that will kind of be brought out when we look at the rate. So the rate's an ALTOU rate, and this is taken from San Diego Gas Electric. Let's just kind of open this up and just take a look more specifically at these charges. So in fact, we do have time of use energy, okay? So clicking into here, we have on peak, off peak, and super off peak. But the main driving thing that I look for is the delta between these two prices. So 11.8 cents versus 9.3. It's a really, really weak TOU pricing. I mean, you might gain a penny and a half after our system losses. So that's not really something I'm super excited about. But instead, let's look at our demand charges, okay? So in the wintertime, we got $20, $20.34 on peak demand charges in the winter, okay? And moving into the summer, that spikes up to $30.59. So obviously demand is the main driving factor of what we want to tell our batteries to target. So that being said, okay, we went in, we went ahead and chose that battery, and I specifically told it to target demand and TOU arbitrage, charging from PV, okay, because again, we have PV on site, and running the optimization, okay? We can see here what our blended savings are. So if we installed one of these batteries, the 250 2-hour battery, our blended savings is $110, just phenomenally high. So that just kind of goes to show when you have an accurate analysis with good rate structures, you know, great hardware, great software, you bring a lot of value to the table here. Energy-wise, okay, we're saving $2,400 just on energy, even though it's a pretty weak energy opportunity. We're still saving $2,400 with this first battery. Demand, we're saving $73,000 with this battery, just shaving demand in this particular example. So as we increase that battery size, of course, we're going to see our demand savings also increase, but it kind of tapers off. So if I was to build one, value-wise, I'd probably go with this 250, okay? You could definitely go with doubling the size if the site might require a little bit extra power for, maybe backup capabilities or microgrid. You might just need that extra power and capacity, and that's okay. So after we model this out, we're gonna go ahead and hit save, kind of return back in here and specifically say, okay, there's our blended savings, right? Here's our analytics, power, charge, discharge, annual cycles, right? 280, again, working in certain markets if that's important to you. We're well over that entry level for SCHIP in California. And what our system losses are after we discharged almost 200,000 kilowatt hours. Okay, but let's take a look into ETB Analytics really quick, and let's just see just visually how this looks. Okay, so as I mentioned before, really spiky demand profile. And the one I showed you before was kind of like smoothed out. It's a seasonal profile curve, but this is a very specific 15-minute interval sort of look. You can see how spiky this really is, okay? So at a glance, right, very spiky. We got our solar PV looped in. Now let's go ahead and add our batteries. So what we can see is that when our batteries are choosing to discharge, right, we can see all these spikes, right, especially during these shoulders. So we have solar PV kind of making up a lot of this demand right here, okay? But when PV winds down for the day, that's when our batteries are going to step in. So we can see that shaving very nicely and looking at our net profile. So here we can actually see when the batteries are operating, we're shaving those peaks. If we take a look at this light blue, let's just zoom in a little bit more here. We can see how nice and level that is, okay? So doing a fantastic job just identifying those peaks and shaving them down nicely. So after we model our battery, okay, again, we got a cost in here for this example, 400,000. It's much larger power output, much larger capacity. $538 per kilowatt hour is actually a pretty good price. We want to add our transaction, okay? So on the transaction side, we want to say add transactions, and this is going to bring up a transaction list. For brand new users, you're not going to have a ton of options until you start building, customizing them. But one that you will have is our ETB Acumen EMS. This specific transaction is in here just to show the license renewal fees and any sort of PV operation and maintenance costs associated with the project. So when you choose this one, it's going to automatically pop in the licensing renewal after 10 years by purchasing our Acumen controls. The upfront cost of the system when you purchase the controls from Energy Toolbase includes the first 10 years. So that's included in the cost, and then if you want to renew it, we show you that in the cash flow. But even with renewing the controls and putting in solar PV operational costs and maintenance, our payback period is still 4 years, and that's including our solar. So very good payback for a project that's price tagged at $1.5 million. And then finally, we're going to get down to our documents. So adding our document templates here, we have a nice list for you guys to choose from. And we have a lot of new ones coming. We actually have a few new ones right in this list that were brand new. One of our account managers' wives is now doing some graphic design for us. She's doing a fantastic job building some new templates. And we're going to have more to come very shortly. So you choose your document. Once you choose, we're going to go ahead and open this up. And then I'm going to quickly just kind of move through the document, very briefly get down to the cash flows. So kind of starting off, you have your cover page, okay? So I built this one for the webinar, but if you guys like it, these are really easy to manipulate. You can customize these document templates any way you need. So scrolling down, right, table of contents, project summary, just talking about the different value streams of the transaction that we're using. Okay, we got our PV system overview, the size of the system, our incentives and net cost, and what we're offsetting from the utility based on our PV gen. Moving down, we have our energy storage analytics. Okay, and this is great because it shows you specifically what equipment we're using, right? So we have one Dynapower 250 2-hour battery, specifically what our power and energy ratings are. And furthermore, the utilization rate. So effectively saying, well, how much effort is this battery actually putting forward in order to undergo our peak demand shaving and energy arbitrage strategy that we chose? And here we can see our battery is very active, as we saw in our analytics with 260 annual cycles. Okay, and then for the battery that costs 400,000, right? There's our net cost. And this is a nice little chart here that we show what kilowatt hour quantity is being discharged from the battery on a monthly basis. We show what the PV gen is, and then sort of like a percent, like out of the total amount of energy created by solar, what percent is battery making up, right? So you actually see here the battery has a very large factor in the overall savings of this project, saving, again, in total $92,000 in this opportunity the very first year. All of our rebates and incentives are going to come next. Okay. And then down towards the bottom, we get to our cash flow. So here we have our total project costs, including battery and solar, okay? We have some nice financial analytics up top. We can see here our operation and maintenance for our solar PV. This is gonna be for some inverter replacements here for our solar side. then here's our license renewal for our controls. Okay, so it automatically pops that in here at year 11. So $71,000 to renew the controls for another 10 years. All things aside, 10 years, 11 years from now, chances are this is going to be cheaper. So if anything, it's going to be more of a conservative approach into the project economics here. But that being said, we have electrical bill savings, okay, year after year, our state and federal incentives, and then our cash flow, okay? So here within the fourth year, almost on the nose, we're looking to be cash flow positive, just really short after that. Just after the end of 20 years, this customer will make about $3.6 million on this investment. So start to finish, really, we try to make it as easy and as streamlined as possible. And as you dive into these opportunities, reach out to your account management. So we're happy to set up screen shares, dive in on these opportunities, and make sure you have the most attractive proposal as possible. Once you guys sell those, let us know. We'll point you in the right direction within our company to coordinate with Dynapower and our team to get these systems ordered and deployed. So that being said, Tracy, that's what I have for you. So I'm gonna go ahead and pass it back.
All right, sounds good. Thank you, Matt. Let me know if you can see my PowerPoint screen here.
Yep, I got you.
Awesome, thank you all. We do have quite a few questions I want to get to. Alan, if you have to jump, please, you know, if you have to jump, you can, but there are some questions we want to get to. The first one, I think, just trying to go down the list here, regarding proposal information being shared, at what level is that proposal information shared with Dynapower? At what level? So maybe Kevin or Matt can handle that one.
Yeah, I can go ahead and jump in on that. It's a good question. Dynapower, they won't have any access to any personal identifiable customer information specific to those proposals. They'll just have the high level project information and specifications that are kind of being modeled, so they can kind of see what the pipeline looks like. So no kind of private or personal information will be available to them.
Great, thank you, Alan. This one was for you. Will Dynapower MPS be on the SCHIP approved equipment list?
Yes, it will.
Okay.
Short answer.
Short and sweet, that's okay. And let's see, what are the application qualifications to use the integration to get approved? Is there anything people need to do, Matt and or Kevin? You can.
Yeah, I can take this one, Tracy. Thank you. So as far as the qualifications, really, first and foremost, click on the integration icon, click accept. That will be sent in automatically. And really, even if you're not specifically working the commercial sector, chances are you're going to get approved. All of our integration partners that we work with have been really great approving just about everybody. I mean, if you're a direct competitor, you might not get approved, and then but chances are everybody will get approved for the integrations.
Okay, thank you, Matt. Somebody did ask when you were modeling in the tool, that 400K that you mentioned, was that including installation? Can you talk a little bit about that?
Absolutely. Yeah, no, that was not including install. Effectively, what I did is I just used a pretty high level number. As far as the installation goes, a lot of these units, they're kind of arriving plug and play. So there's a lot of factors that are involved on site, concrete padding, wiring, conduit, a lot of different things. So the 400K is a little bit of an arbitrary number. I kind of just took the system cost to purchase the hardware and the software. I added a little bit of margin into it. Like I think I added about 15 or 20% to make it more of a realistic number. But the installation cost is going to change based on the customer and the nature of the project. So I added a little bit more into it. So the actual purchase cost is a little bit lower, but that number will change based on the project.
Thank you, Matt. Alan, I will give this one to you. Someone asked, most places in my area require UL 9540 or better certification to meet fire code. Is the MPS 125 certified?
Another easy answer, yes it is.
The easier, the better. Okay, great. We did have some more. And I know Matt kind of touched on this a little bit, but if a user is modeling a system and sells it, after that, what are the steps to take after that once it's modeled and sold, and what teams are kind of involved in that? Maybe I'll throw that to Kevin.
Yeah, for sure. So our account managers will kind of walk through the process, but when a project's ready to move forward, we are working with Dynapower to have a smooth, easy transaction where a single PO can be issued to Energy Toolbase that will cover the equipment from Dynapower, the battery, inverter, anything from them, as well as the Acumen EMS for a nice one easy transaction through ETB. And it'll be working, closely with your account manager as well as, either myself or Mike Avanonis on our operations team here at Energy Toolbase will help through the kind of deployment side of the project.
Great, thank you. This one was a question I did want to address. And it's kind of touching on a different product that we didn't talk about today, our ETB Monitor product. But once a system is modeled, designed, and in operation, can the Energy Toolbase platform track the actual operation of the system? So I maybe want to toss that to Matt and Kevin to jointly talk about that.
Yeah, absolutely. Yeah, Kevin, I can start off and chime in however you see fit here. But yeah, once those systems are deployed in the field, yeah, ETB Monitor. So when you buy Acumen controls, you're going to get the monitoring system as well. So therefore, you could see in real time what's going on, on that site, as far as the battery performance, the solar PV performance, what should be pulling into the site, from the grid. And then Kevin, you can expand a little bit more on the different maybe viewpoints of as an entire site and how that's coordinated. But you will be able to monitor, absolutely.
Yeah, one thing I can add to that is part of the hardware integration work that we do with Dynapower, and that's part of what I kind of work with between their engineering team and ours, is kind of ensuring that we really truly understand everything that's going on within their ecosystem. So that might end up being specific alerts that need to be paid attention to, and anything critical will be kind of relayed through the ETB Monitor platform for systems live in the field, and these can be customized. There's a lot of features that we're developing for the new product at ETB Monitor that will kind of advance over the course of the year, but you should be able to kind of see everything that you want to see out of your system and also kind of be alerted to any issues that might occur specific to that equipment.
Thank you, guys. There is one, Alan, I was going to ask you this. In the platform, we saw the 2-hour and the 4-hour options. Is there a 6-hour option, or what about the 6-hour option?
Right now, I don't think a 6-hour option is available, and it's not on our roadmap. We're staying, I think, within the 2 and the 4, mostly because of how much energy you have to store in that relatively small space. Once you get past that, you're going to go to generally a separate enclosure, like 8x10 or 8x20 enclosure to put all your energy storage.
Thank you, Alan. And yeah, if you have any questions like that and you're modeling with this integration, please just contact your account manager. They can help answer these questions as you go as well. Matt, I wanted to ask you a question about transactions for this integration, if there's anything that will be dropped in accounts if people need them.
Yeah, absolutely. Yeah, thanks, Tracy. So as far as it goes, yeah, when you're modeling within the integration, especially if you're using one of the integrations that are hosting Acumen controls, yeah, on approval, you will have access to the Acumen cash purchase option, and I believe there's going to be a loan option as well in your account. So from there, we can manipulate that to show different types of loans and different aspects of a cash transaction. But yeah, those will be in your account as I kind of showcased kind of in my run through. But yes, they will be available.
Great, and then I'm gonna throw this last one at you, and then we can wrap up. Who should, users reach out to for support? Will it be a joint effort, or will it be mostly an account manager with the Energy Toolbase team?
Yeah, I mean, that's a great question. I mean, to start off, I would say reach out to your dedicated account manager. From there, we can put eyes on the proposal, make sure everything looks good. If there's anything that we need to bring in a second set of eyes on, we absolutely will. We can bring in Kevin, we can bring in Susan or Chris Safel, a lot of the people that know very, detailed examples and, information about these systems that can help. So it kind of goes both ways. So yeah, we'll bring in anybody we need to, and then from there, just make sure that everything's designed and everything's looking great to present to the customer and close some deals.
All right, thank you, Matt. That's what it's all about, right?
That's right.
So we're gonna end the Q&A there. We really appreciate it. It was really interactive. You guys asked some really great questions. If you are a user and you want to reach out to your account manager to kind of sit down with them and walk you through this integration and answer more of those questions, please do so. That's what they are there for. After this, in a couple hours, we're going to be sending out an email. This will have the recording of it and some other information, contact information of our team. Alan, is there a good contact we can send if people want to reach out, maybe to you or?
I'm probably going to be the best one, so just put down my email address and that should be the best contact for anybody at this point.
All right, thank you. Again, if you are a user, please apply for that, and you'll be using that integration in no time once you're approved. And if you're not a user, we want to offer you a 30-day free trial. It's usually 2 weeks, but we're extending it to a month for that trial if you want to get in there and kind of explore the integration. During that trial, you have full access to the integration, and you can use it just how everybody else would. Once you do sign up using the link we'll send out, just put the Dynapower webinar in the referral box, or just let your account manager know that you came from this webinar, just so we can track that and make sure you get those 30 days. So yeah, be on the lookout for that email after, and we're excited for you guys to get started using this integration. As you saw, it's pretty powerful, and we're excited to have the Dynapower team integrated with us, and we're going to continue working with them, and I think it'll be, you guys will be very happy. So please reach out to us with any additional questions about the integration, Energy Toolbase in general, and we can answer those for you. Thank you to our speakers for being on, and have a great day.
Thanks, Tracy.